Solving systems by substitution. So far, we've looked at two ways to solve systems of equations. The first way was by graphing. In this format, we remember that using the 3, that's our y-intercept and our starting point there, and we have a slope of 2 over 1, so up 2 over 1, up 2 over 1. This is being a little unfriendly today. And we end up with a line kind of like this. In the second equation, I have a starting point, or f of 0, at 4. I have a slope of negative 1/3, so remember that's down 1 over 3. And I draw a line in here like this. And so in this case, our solution point is right about there. And normally we put that solution in an ordered pair format. Notice in this case, although my line is off a little, I don't have whole numbers, I don't believe, as my solution. And this is the problem with graphing. Graphing is good because I can see it, but not always good if my answer doesn't end up being whole numbers. So that's why we need other methods. The second method we studied was elimination. Elimination, remember, involved eliminating or getting rid of either the x terms or the y terms. So in this case, the first thing, remember, that I look for is, do I have two terms that are exact opposites? In this case, I have 3x and 3x. I have negative 4y, and I have 6y. I don't have exact opposites, but I do have same. So if I can turn one of those into a negative, then I've got my opposites. So I'm going to multiply the top row by negative 1, and doing that would give me sign changes all the way across. Now I'm ready to go ahead and solve. The 3x terms are gone. I have 10y equals negative 20. Do a division. Y is negative 2. Just because I've got y doesn't mean I'm done. I have to find x. So I'm going to go ahead and take that top equation and put the negative 2 in place of y. Then I can continue to solve and find out what x is. So I get 3x plus 8 is 12. Subtract the 8 over. And in this case, x is going to give me 4 over 3. So my solution is 4/3, negative 2. Again, if we'd graphed this, this wouldn't have been a good graph because we end up with a fractional value. Today we're going to look at how to substitute, or how to replace, one of the variables for the other. Think about with substitution, when you have a substitute teacher, you get a different teacher in place of the one you normally have. Or in sports, if a player gets hurt or tired, they might substitute a different player in for the main player. Our first example, we have y equals x minus 4 and y equals 3 times x plus 2. Notice here that both sides equal y. So what we can do is we can say that x minus 4 equals 3x plus 2. Now, something to remember here if you have trouble with this idea. We know that 4 is equal to 3 plus 1. We know that 4 is also equal to 2 plus 2. So we're able then to say that 3 plus 1 equals 2 plus 2, and that's a true statement. So we substituted because they were both equal to the same thing. All right, so now that we've gotten rid of the y's because they were both y equals, now we have to get our variables to one side. So I'm going to go ahead and move my 3x to the other side because I like my variables on the left. So now I have negative 2 times x minus 4 equals 2. Now I'm going to move my constants to the same side. So now I have negative 2x equals 6. And then, of course, I'm going to finish up with a division. And in this case, x will equal negative 3. Okay, I'm not quite done yet. We found x, we still need to find y. So over here, and I do need to make a correction here because I made a mistake. X was not 1.5, x was negative 3. So now all I want to do is take the first equation I had, so I've only copied one of them, and this negative 3 is going to substitute for x. So y is equal to negative 3 minus 4. Y is equal to negative 7. So we're talking about always solutions. The solution is negative 3, negative 7. So for some people, the substitution method is a little nicer than the other two. One more time. I have y equals negative 1 times x plus 7, and y equals negative 2 times x minus 9. Again, they are both in this format, so I can go right to saying that negative x plus 7 equals 2 times x minus 9. Again, the goal is to get my variables to one side and then my constants to the other. So this time I have negative 3 times x plus 7 equals negative 9. I'm going to go ahead again and move my constants over to the right. So now negative 3x equals negative 16. And then finally we know we're going to finish up with a division. So I know that x is equal to 16 over 3. Not a very pretty answer, but they don't always end up as whole numbers. Again, I have x. Now I need to find y. Okay, so I'm taking the first equation we had from last time and the answer of y equals 16 thirds. Oops, except it's not y equals this time. It was going to be, I'm not doing very well today. X equals 16 thirds. So this 16 thirds piece will become y equals negative 16 thirds plus 7. If you don't like fractions, remember you can put this into your calculator like this to go ahead and give you y. This will give you y equals 1.6 repeating, or depending on your calculator, 1 2/3. Again, we need to finish with our solution, and our solution in this case is 16 thirds and 1 2/3. Alright, now I'm going to give you time to practice a couple of questions before you move on. Let's change things just a little bit. Notice this time I don't have the two y equal pieces, so they're not both like this. But I do notice I have one y equals. So if that's what y equals, that whole piece can replace the y. So This piece right here is going to go right there and replace that y. So this time what this is going to look like is 2 times x minus 4. Notice I'm not changing anything. The only thing that's going to change is where the y was. Alright, now I've got to do a little bit of distributive property. So I've got 2x minus 4 times x. Negative 4 times negative 3 is a positive 12. I need to combine like terms right here. So negative 2x plus 12 is 10. I need to move that 12 to the other side so the constants are together. And so negative 2x equals negative 2. Finish with your division. X is 1. Okay, a little more work on this one, but still not bad. We have x, and one more time, we need to go ahead and find y. I took the top equation from last time. I know that x is 1, so that 1 is going to go right there. So y is going to equal 1 minus 3. So y equals negative 2. So again, we talk about a solution. My solution is at 1, negative 2. Now I'm going to go ahead and let you practice this type of substitution problem. Okay, one more step, a tiny bit more complex. Notice this time we have no y equals y equals. We have nothing that says y equals and, for example, 3x plus 2y equals 5. So we need to solve for y, or x, depending on the problem. So I need to get this by itself. So I'm going to go ahead and take 2x plus y equals 9. I'm going to subtract the x term to the other side. So y will equal 9 minus 2x. Now I have a piece that can get put right there. So just like we did on the previous screens, I'm going to go ahead and take negative 4x plus 3 times 9 minus 2 times x equals 7. And I'm going to solve that down. So negative 4x, 3 times 9 is 27, 3 times negative 2, combining like terms, subtracting the 27 to the other side, just because I'm running out of room, and doing a division, x equals 2. Now we do remember that because we found x, of course we need to go back and find that y value. So I'm going to go ahead, and again I like using the top equation. So that top equation, 2 times 2 plus y is 9. 4 plus y is 9. Subtract y is 5. And I'm going to get a solution of 2, 5. One more time with that idea, but this time I'm going to work with this one. So I'm going to go ahead and take x plus 6y is negative 7. I'm going to subtract the 6 times y to the other side, so I'm solving it for x. So again, as I think about highlighting something, this piece is going to go in the top equation right there. So as I rewrite this with the top equation, 3 times negative 7 minus 6y plus y equals 13. Distributive property, 3 times negative 7, 3 times negative 6. Combining like terms. This gets a little messy. I'm going to add 21 to both sides. Do my division. So y is at negative 2. Again, I have to go ahead and finish this up so that y value has to go back up into either the top or the bottom. I'm going to go ahead and stick that into the top equation right there. So working through that, I get 3x minus 2 is 13. 3 times x equals 15. Doing my division, and I end up with a solution of 5, negative 2. Again, I'm going to let you practice these just a little bit. Okay, finally, how does this work? Jimmy stopped at Quick Trip 2 days this week on his way home from school. On Tuesday, he bought 2 candy bars and 1 soda and spent $3.26. On Thursday, he bought 1 candy bar and 2 sodas and spent $2.67. Find the cost of 1 candy bar and the cost of 1 soda. Well, with equations, I could have y equals negative 2x plus $3.26. I could also have y equals negative 1/2 x plus 1.335. That's what this graph represents. But notice where the point of the solution is on this thing. So that solution is right here. And it's not a pretty solution on a graph. So while we can see the solution, because it's kind of in the middle of the box, we don't know exactly what it is. So I used the same question, and I went over to the elimination method. So in the elimination method, I've got these two equations. I multiplied by negative 2 on the bottom, and then I solved for y. I put the y back into the bottom equation, so I fit that back in right there, and we found x. So we would find out here, more easily than the graph, that a soda, the soda is about 69 cents, and a candy bar is about $1.28. Okay? If I don't like doing elimination, if I prefer substitution, then here I took that top equation and I solved it for y, and then I took that value and replaced it into the second equation, and here is my x, or my candy bar, at $1.28. Then I went down and found y, and there is my soda. So 3 ways to solve the same problem.